So I've just started the lecture. I am recording the lecture, so that's something to note. So I record my lectures, it just comes up even more. So how many of you got my, yes, hi, 2168? Come on, take a seat. Okay, so, so as I was saying, the lectures will be recorded, which is part of the reason I'm facing this way, right? So I don't capture any view necessarily, because then otherwise I'd probably have to get some other, I don't know if I have to get forms signed at that point or whatnot. I think verbal permission works at that point. But anyway, most of the lectures are going to be flipped for this course. So did everybody get that email last night? It may have just simply come as an announcement from Canvas. So it's okay if you didn't read it, because that was sent yesterday, and technically school hadn't started yet. So you aren't responsible for anything, you know, at that point. Unless, you know, you might have just only joined the section, which was created just a bit. And I'm sure there will be reshuffling, right? There will be people who from this section who might move into another and other way around. But anyway, most of these, the emails basically said that most of these lectures will be flipped. So what does that mean? Well, that means that these lectures, I tried this out from in 1068 and 2168 for last semester. But that means that basically you typically do homework at home and do your lectures in the classroom. Flipping the lecture means we do the reverse. You're going to be doing your lectures at home and your homework in the classroom. This should not add any additional time for you guys. Should not. And in fact, it will mean that the time you spend working on your homework will be done more efficiently, because you're going to be here with me, you know, and I'll be able to answer your questions. Especially since it's a one-section room, so that means I'll be able to answer your questions a lot more effectively than the class at noon. But that means that, and I'm not going to, and some professors, they're terrible about like flip lectures. They give way too long videos. The videos are too long. There's too much stuff in there. You're going to get about 2 to 3 hours of video a week, which is about the amount of time you'd spend listening to me drone on in a classroom, okay? And I'll be doing you the favor of dividing these videos into nice, digestible 10 to 15-minute videos, right? That means that you guys will be able to watch a nice chunk of digestible information, and you'll be able to do that. So I'm going to show you where you can find the lectures that you'll need to watch. So let's go ahead. So you'll find everything on Canvas. And I may have discovered, you know, just by reading the small instructions they gave me, that you can actually input a animated GIF for the course image, which I totally took advantage of, because, you know, that seems like an oversight on their part, I feel. So anyway, when I post an announcement here, you should be getting an email from Canvas, so hopefully you will have gotten these emails. If not, just tell me later that you aren't getting the announcements. There's just been 2. If you've only just, like, if you literally only just registered for the course, like, before noon, then you probably, or right after noon, then you probably haven't gotten this yet, or the announcements yet. All right, so most of the stuff you can find on Canvas, or get linked to on Canvas. But I explained the whole concept of this flipped lectures, and that you'll be watching the lectures outside of class, and in class you'll be doing the work, including today. We'll use that to get started. Wednesday basically will be barely a bit of me droning on, and okay, so let's go. So here's the important thing under Pages. That's like the most important part of Canvas right here. Okay, first is this link to a video, Crash Course Data Structures, which is a video done by the channel Crash Course. Great people. They did it. They have a computer science playlist which talks about a lot of concepts in computer science, which are really great. But their video on data structures is like a 10-minute overview of everything that's going to happen in this course. Next is this GitHub class link, where if you click it, it will bring you to. You'll have another link to my to my repository on GitHub. And let's just zoom in here, right? So all the code can be found in the dstruct folder for data structures, okay? Fall 2017, that's obviously last year, and spring 2018, that's last semester's, but there's all the code from the previous semesters. And then I'll be organizing each of the, each segment that we do into its own package, its own folder, and you can find all the code that I write there. Okay, so if you're trying to furiously copy down stuff while you're watching the video, you don't have to worry about it too much. It's also better. You also get better retention. Studies have shown if you actually write stuff down via your notebook. So if you're worried about missing something, you can always find it there for reference. The third link over here is where I'll be posting the lectures under lectures. So first is this YouTube playlist over here. Right, you can click this over here to go to YouTube, the link over there, and it'll bring you to the playlist with all the video. I've already posted a review on reviewing the inheritance concepts. There may be some stuff you may not have learned, like how to use the super function, how to use the this keyword to call other constructors, or not the super keyword, but the super function, but the super keyword. So that's stuff you may not have learned. And these are just simply things going over how we review what are object and classes, how do we write those, inheritance, and then polymorphism, and then going over some other things like the for each loop and the instance of operator that may not have been taught, definitely not taught, but is because it's a small edge case. But notice that the videos, they're small, they're easy to digest relatively. I think the rule of thumb is like it should be a minute per grade level, so in general. So, and I also happen to have posted like the full lectures from last semester here, and you can find the entire playlist here. You can also
Hi, I'm Professor Rosen. So rather than burning the first lecture or the first half,
I'm not that egotistical. Okay, so you can hit the top left corner over here, and you'll be able to find a playlist of videos, and you'll be able to select the one you need. Okay. So with that, I'm going to go over the other aspects of the syllabus. But any questions about the concept of the flipped lecture? Right? You'll be watching videos outside of class, no more than you'd be spending inside class listening to me, and rather than and the majority of your time on homework shouldn't be outside of class, it should be in here. You probably will end up spending some time on homework outside of class, but hopefully a lot less, especially since you'll have a lot more opportunities to interact with me, right? And that's what the labs are for as well. The labs and assignments, they're the same thing. Labs and assignments are the same thing, and the lab is just more time for you guys to work. So a lot of time spent working here. Now, so that's part of the reason why it's important for you to have a laptop, but a lot of the programs hopefully will be done. My plan is a lot of these programs will be done in pairs. You'll be working with another person, that meaning like only half the people have to have laptops in that case. So there will be a lot of paired programming, and we're going to learn about how to do that more effectively. That way you can work with other people. That was an interesting sound. Okay, so let's go ahead and take a look at my syllabus. So, all right. So, course details. The first week or so, this week we're going to be going over inheritance and generics. Is primarily what we'll be tackling. So this is concepts from the inheritance and polymorphism you should have gotten from 1068. Generics, they're a useful feature in the Java programming language as well as other programming languages. Some programming languages like Google's Go doesn't have generics, and when you don't have them, you kind of miss them. What generics allow you to do is rather than saying I have a list of stuff or a collection of stuff, you can say it's a collection of integers or a list of integers or a list of strings, and that means you restrict access to it. Only strings can be put into this, but as a result, I can assume that if I'm grabbing an object from this list or a selection or a collection, what I'm grabbing is going to be a string, right? So that's kind of a useful thing. You can't accidentally put a integer into an array into a list of strings. An array list. So then we're going to learn about lists. So we're going to learn about array lists and linked lists, which are two different ways of building lists. Array lists, we just simply build a list by allocating giant chunks of sequential chunks of memory, whereas linked lists are built by basically creating a scavenger hunt through your computer's memory, where each item in the list points to the next item in the list. We'll also learn about time complexity and algorithmic efficiency in order to learn how to compare different implementations of building a list. These concepts will be about the first 4 weeks of class, and they'll make up the bulk of the first exam, which is around week 5. This is week 1, so week 5 is your first exam. Week 5 or 6, right? I've delayed it before, where often to week 6, but this will be the bulk of the content. And depending on how fast we go or how well it goes, stacks and queues might make it on there, but a little bit. Stacks and queues, once we're done with linked lists or array lists, since they are built using a lot of the same concepts that we just went over in array lists and linked lists, they take about a lecture apiece because they're much simpler data structures. But just because they're simpler doesn't mean they're, you can't use them in very elegant ways. Then we'll go over recursion. We'll be looking at examples as to how recursion can be useful to make your code a lot cleaner, a lot more elegant, and how we can use recursion to basically break down really complex problems into much simpler solutions. So we can use them to solve we'll examine solving mazes and solving some various chess problems. Then we'll go over trees and heaps, and then this chunk of the class will be a lot of the second exam, which will be around week 10 or 11. Sorting algorithms, we'll go over a lot of sorting algorithms in this class. We'll go over hash tables, which I'm a big fan of, and then we'll tackle graphs at the very end of the class. The graphs get taught in a lot of mathematical concepts classes, but I'm going to assume also that it's your first exposure to graphs. And I'm going to assume that in hash tables you learn about mathematical sets in hash tables. I'm going to assume, though, that everybody's learned what a mathematical set is. And even if you can't remember it, it's a very easy concept to understand. Okay? Time and place, you found it. Congratulations. So we're done with that part. Please attend the lab that according to your section. So I believe that's Thursday at 3. Okay? The prereqs for this course, get a C in 1166 and 1068. If you got a C in 1068, you may not be prepared for this class, so just be aware of that. Use your own judgment as to why you got a C, right? Is it because you just didn't have a proper work ethic, guilty, or because you struggled with the material, right?
Isn't this 2168?
C, sorry. That's a typo, and those things happen. I'm just keeping you on your toes. All right, so textbook. I've ordered the 3rd edition of the textbook. We've been using the 2nd edition previously. If you've got the 2nd edition, that's perfectly fine. Just be aware that there's a new chapter. And what they did is that the way we viewed the textbook got reordered is that they took chapter 3, which was stacks, and moved it into chapter 4. So now chapter 4 is stacks and queues, and chapter 3 is all about testing. That's really it. We'll go over most of the textbook. We might skip chapter 3, which is the testing chapter, but I hope to tackle some of it. And we probably won't get to chapter 9 simply because of time constraints. It's all about self-balancing trees. You'll understand the concept of them. That's just a chapter about how to build them. And that's only because I like to get plenty of time to go over some graphs and stuff. My office hours, this is my room. This is this building, room 349. My office hours are Monday and Wednesday, so before this class from 2:15 to 3:15. I'm aware that this may not work for all of you. You might have a class like during this time. That's okay. I am extremely accessible. If you need to meet me on campus, I will make an effort to get here to meet you. And if we can't coordinate a time to meet on campus, we'll meet via WebEx or Skype or the video messenger of your choice, on when I'm not on campus. And I can do, particularly late hours. I've met students like at 8 or 9, and that's perfectly fine. Only thing is that when it's that late, you'll just have to work around me getting my toddler to bed. So, So I've got the TAs listed. GIE who I believe is supposed to be the TA for this section. I think we've had a bit of a snag with her, so that's kind of up in the air. Like she has some requirements that technically need to be taken care of before she can be a TA, but I don't think she's going to have any problems with that. So right now the office hours and office locations of everybody has to be plugged in. But notice that I did not list like who's your TA in this, right, or anybody's section's TA. That's because, as far as I'm concerned, you can go to any of these TAs since they're all going over the same content. So you can go to any TA. Right? You can go to any TA and you can go to speak to any of these people during any of their office hours. I just have to plug that in and I'll update the syllabus and I'll post an announcement saying the syllabus has been updated. Okay? Especially since we're doing a lot of work in class and they'll be doing quizzes in class, I'm expecting you to show up to the lectures and the labs. If you arrive late, don't make a big deal about it. That's it. It's fine. It happens. The train gets delayed sometimes. The subway gets delayed sometimes. Sometimes there's somebody really pestering you on this, on the way to class. It's fine. If you're ill, just shoot me an email. Don't come to class. If you're sick, get better. Just shoot me an email. We'll be adults about it. I'll either excuse you from the work or I will tell you to make it up at some point. Okay? Same thing for exams. If you're sick, just shoot me an email, let me know you can't make it to the exam, preferably before the exam actually starts, right? Also, if you've got like some kind of like, if there's like a wedding going on or you have to go out of town or something, the sooner you let me know with regards to exams, the earlier we can work around it and come up with, and I can book time in my schedule to make sure that you can get a makeup. Don't cheat. Don't copy work on the internet. Don't grab stuff from the internet. If you're in doubt, provide citation. Now, a lot of times you are going to be working with another person, right? And in those cases where, like with this first homework, it's perfectly acceptable for you to both submit the same exact thing and show me the same exact thing because you're working on the same exact thing. It doesn't make sense otherwise, right? But you're encouraged to work with your classmates and to collaborate with them. But if you're working on an assignment by yourself, we expect you to turn in your own work. Collaborating with someone else is not cheating. Saying, hey, can I see your, emailing somebody else and saying, hey, can I see your code? I'm having trouble with this. Can I see how you solved it? And then basically getting the other person's code and then changing the name on it and submitting that work on your own. Yeah, that's totally cheating. Don't do that. It's very easy to detect. In fact, it is not beyond the realm of reason for me to give an assignment that is a plagiarism detection program in this class. That's something I could totally do in this class. Give you an assignment that detects plagiarism. It's very easy to detect plagiarism. So if you've got a disability, go through DRS and let me know, and I'll make all the accommodations that I need to. Okay. And again, I record stuff, so just be aware of that. I think that's all I have to I just have to let you know I'm recording. So, grading. So generally, you need above a 70 in this class to pass. I generally don't curve in that manner. Your raw score does have to be a 70 or above. That being said, I do curve like the ranges. So like last semester, like an 89 or 88 was an A, and like 77 was like a B, right? So that's kind of what gets adjusted, okay? And that depends from semester to semester based on the scores. And I also try not to be a jerk. I try not to be a jerk about it, like, oh, this person got an 89.1, but you got an 88.8, so you get a B, whereas this person gets an A. I don't work like that, right? Those cases, I don't work like that. Generally, the way that works is, I've done that in the past, is that generally students, they produce nice gaps, right? There's a couple of points between an A and a B, generally. Okay. There's plenty of extra credit opportunities, and now assignments are worth points, but those points are only relative based on each category. So like say, for example, they won't be weighted like this. Say you have a 1-point quiz and a 100-point quiz, right? Then that 100-point quiz is worth 100 times as much as the 1-point quiz. It obviously won't work like that, right? They're going to be much more consistent with each other. But they only apply for the quiz grades. Those points are only quiz points, okay? That's just simply the way the system works, and so I just simply take advantage of the system and make it easy. So quizzes are about 10%. You'll be getting at least one a week. Those will be done. You will do your quizzes either on the computer or on the phone. They don't. The coding there won't be intensive because, again, if you're doing it on your phone, that's kind of difficult. Most coding questions if you have to write code, it will generally be a Parsons puzzle, which means that I already wrote the code. They're just in drop-down menus, and you have to order the code correctly in the drop-down menus, essentially. Labs and assignments are the same thing, right? Basically, these are put anything with a long due date, like a week-long due date, in this category, right? These are things where basically you have a 10-minute time limit to complete them, essentially. These timed labs, there are going to be about 3 of them. View them as mini exams. They'll be interspaced. You'll take them in between each of the exams. So one at week 3 and then one between week 5 and week 10, essentially. And there'll be 3 of them, so each of them is about a third of, 3% of your grade. So not too much, but not too little at the same time. If you took these in 1068, you'll be pleased to know you'll have a longer time limit, and also because, that's what worked. And also these tend to have better, students tend to do better in 2168 on these timed labs than in 1068. Then the exams then you've got 2 exams, each worth 15%, and their finals worth 25%. Now, the final exam does have a reputation for being difficult, but I don't necessarily think that's because the final itself is tough. I think it more has to do with the fact that that the final exam is typically the second week of exams, right? It's on the Tuesday. So it's on the second week of exams, and it's final season. It has to do with the fact that basically there's just finals going on at the time. So it's less about the exam and more about that there's just a lot of stuff to study, and you have a lot of other stuff to study already, so that's just a pain in the butt. All right? The last thing I really have to go over is how you turn in your assignments, which is, it's a 2-part process. The first part, turn it in on Canvas. Just upload it. This gives you a timestamp and a way to prove that you did upload it. Okay? And in case we mess up in the second step, you can point out to me that you did do it. And the second step is demoing it, which means coming to me or the TA, any of the TAs, and saying, this is what I did, and this is how it worked. Basically coming to me, showing me your code, and and then I'll ask you some questions about it. Like for this code, I will ask you to explain, like for this program, I'll ask you to explain the strategy for your rabbit, which is the assignment we'll be working on today. So you do not get credit unless you come to me and demo it. And you can do it here in the lecture, you can do it in the lab, period, or you can do it during my office hours, okay? Okay, the rest of that, it's fairly straightforward. My late policy is this equation over here, which looks complicated. Essentially, it means 5% off per day. Not 5 points, 5%. So first day late, 95, second day late, 90.25. So basically, you lose less than 5 points the second day. This allows you to basically turn in something for credit at any point, although if it's later than 10 days, I need a reason why it's later than 10 days, okay? It doesn't have to be the most amazing reason ever. I just need a reason. Okay? Final exam, that has to be updated because I failed to do that in my syllabus, right? Still got the spring times up there, but they are generally, the final exams, you can find that on I don't know why I'm required to put the final exam times in my syllabus, because because the way I figure them out is the same way you're going to figure them out, which is you go to the final exam schedule that's on the calendar. You apparently have rights, believe it or not, so you should click on this link and find out what they are, because you do have rights. You'll be surprised at what they are. Like, there's some policies there as to how many finals you're allowed to take in a single day. The answer is 2. You're allowed to take 2 and no more. So, so stuff like that you can find in that handbook. And then I've got a bunch of tips for succeeding in this class just listed here. Okay, so be sure to take a look at the syllabus and read over it for all the details. And as I change, if it gets changed, because there's some things that may make changes to it, we'll need to upload it. All right. So with that being said, right, I guess it's time to get to work. So what I want you guys to do is I want you to pair up into groups of 2, and each pair needs to have a working laptop, essentially, to work on. So I know that there's plenty of people who did not bring their laptops today, but for right now, pair up into groups of 2, and each of you need basically a working laptop. I think are there power outlets? I think there's some over there. If you need some over there, you know. Oh, there's some on the floor too. But yeah, there's plenty. There's on the floor over there. Yes.
So we don't need to like download any software.
Something to code with, but generally, you can. But worst case scenario, you can download something pretty light to do some coding on. If you don't want to download NetBeans, you can download something like what do you have, Mac?
So I have a Windows machine. It's like in the Stone Age, so I don't use it for school. I just write from the text on it.
Okay, so is it a laptop?
Yeah, like they have one there, but
No, your laptop.
Oh, mine's
It's old.
Yeah.
How old is it?
Maybe 2009.
I need to know the specs, but you can. Sorry. But I can. Yeah, if you can use NetBeans on it, then we can always install Linux on that and get it to be fast and usable. Okay. So long as you're okay with backing up all your data first. Yeah. You'll have to back up all your data, but we can turn that into a very usable laptop very quickly.
Okay.
By quickly, I mean an hour. So. Okay. All right. So. All right. Let me stop recording.